Welcome back, students! Let's dive right into today's explainer for Class 4, Building and Managing Inventory Data. Now, if there's one absolute golden rule you take away from this entire course, it's this. Your impact assessment is literally only as reliable as the inventory data you plug into it. Seriously, if you build your foundation on guesswork, your final results, yeah, they're going to be exactly that, just guesswork. So our main mission today is to make absolutely sure you know exactly how to gather, structure, and rigorously evaluate your data before you even think about generating those final calculations. Let's get to it. Think of me as your guide through today's playbook. We're going to start with your data mission, master some key terms, and then walk through a really clear 3-step process: building your BOM, creating your inventory, and finally checking that data quality.
All right, Section 1. Your data mission starts here. Translating a product into structured flows.
So, to reiterate that crucial takeaway, an impact assessment is only as reliable as the inventory on which it's based. In this class, we're really focusing on that critical phase where you take a physical product or a process and translate it into structured data. You're mapping out all the flows, materials, energy, transport, emissions, waste, outputs, the whole shebang. You absolutely have to organize this data into a format that works for footprint calc or whatever comparable tool you're using before you do any actual assessing. Look, if your data isn't structured right from the get-go, the software simply can't help you.
Okay, moving on to Section 2. Master the key terms. This is the vocabulary for your assessment. We really need to lock down a few essential concepts before you start your assignment. And we're going to use a simple 1-liter bottle of water as our working example today. First up is the BOM, or the bill of materials. You can basically think of this as the physical stuff that actually makes up your product. So for our bottled water example, your BOM would list out the specific mass of the plastic bottle itself, the mass of the plastic cap, maybe that paper label, and of course the actual water inside. It's really just a simple list of components, the specific materials they're made of, and their exact quantities. Now, let's build on that with the LCI, or Life Cycle Inventory. You'll notice right away that the LCI is way broader than the bill of materials. While the BOM just tells us what the bottle is made of, the LCI tracks everything required across the relevant life cycle stages. This data set includes things like the electricity used by the factory machines to mold that plastic, the water consumed in the facility, the transport distances needed to move the bottle to the grocery store, and all the emissions and waste flows generated along the entire journey. As student researchers, there's a vital distinction you have to make here. When you're building your LCI, you're going to run into 2 very different types of data. First, you have foreground data. This is the specific info you can directly observe or measure for the system you're studying, like the actual weight of your specific water bottle or the electricity use of the exact facility you're looking at. Background data, on the other hand, is the information you'll need to pull from existing databases. Think standard emission factors or generic material production datasets. You absolutely need to know exactly which is which. Right, let's get practical. Section 3, Step 1, build your BOM. This right here is your Activity 1 playbook. For Activity 1, your final output needs to look exactly like the table we're looking at. Every single component must be listed out. You'll need to fill out the material type, the quantity, the unit of measurement, and, this is huge, your exact data source. You also have to include a column for conversion notes. This ensures your methodology is totally 100% transparent to whoever is reviewing your work. But wait, before you wrap up Activity 1, you have to do this. Convert all quantities to the functional unit. What does that actually mean in practice? Well, if your functional unit is 1 liter of bottled water, then literally all the data, the cap mass, the bottle mass, the transport distance, the electricity used, all of it must relate back to that exact reference flow. You have to check your units meticulously and document your assumptions so everything aligns perfectly. Don't skip this step. Moving right along to Section 4. Step 2, create the inventory. And here is your Activity 2 playbook. We're going to follow a very exact progression to build upon your initial work. First, you start with the BOM components you literally just mapped out. Second, you layer in the energy and water use required for the process. Third, you add in your transport data. And fourth, you factor in the resulting emissions and waste flows. Using this systematic approach is a real game changer because it ensures you don't accidentally miss any critical inputs or outputs across those life cycle stages. Now, as you construct this massive, comprehensive table, keep this crucial directive in mind.
Actively separate your foreground data from your background data. Within your final spreadsheet modeling, you need to clearly distinguish the observable data that you measured directly from the standardized data that you had to pull from a database. This separation is absolutely crucial for maintaining transparency in your final assessment. Okay, so you've built your inventory. You might be sitting there thinking you're completely done, but I have a bit of a challenge for you. Just how reliable is your data, really? Have you actually captured everything? Are your baseline assumptions actually sound? Which brings us to Section 5. Step 3, check data quality. This is your Activity 3 playbook, and it focuses heavily on practical, real-world data management. When you're evaluating the confidence levels of your inventory items, you need to assess these exact criteria. Ask yourself, is your data complete? Is it consistent across the board? How accurate is it really? You also need to look closely at representativeness, and by that I mean both temporal and geographical. Basically, is your data from the right time period and the correct location for the specific product you are studying? And finally, you absolutely must account for the overall uncertainty in your numbers. So for your Activity 3 deliverables, here are your precise execution steps. First, go through your entire inventory and explicitly mark each item as high, medium, or low confidence, and be sure to explain why. Second, actively hunt down any missing values, questionable assumptions, or unit inconsistencies. And third, this is a specific requirement for your assignment, so listen up. You must generate a data quality log that documents at least 5 specific issues, right alongside your proposed ways to improve or document them. Now, you might be wondering why we're being quite so rigorous about all of this. Well, here is the big payoff. Out there in the real world, having perfectly exact data is incredibly rare. By documenting your estimates right now and explaining how those estimates might influence your final results, you are fully preparing yourself for interpreting impact hotspots and dealing with uncertainty later on in the course. Doing this properly now literally sets you up for absolute success down the line. And that brings us to the end of today's explainer. I'm going to leave you with one final question. Are you ready to build an inventory that guarantees a reliable impact assessment? Just remember, a single bad data point today means a completely flawed environmental policy tomorrow. So take this playbook, go confidently tackle your Class 4 assignment, and ensure your data foundation is rock solid. Good luck with the assignment, students. You've got this.